ORMs are a foundational tool in modern software development. They act as a bridge, letting us interact with a relational database using our preferred programming language, instead of writing lines and lines of SQL. We define our data structures as objects or classes, and the ORM intelligently maps them to database tables. Need to fetch a user? You simply call a method on an object. This approach, known as Object-Relational Mapping, feels intuitive, provides type safety, and dramatically boosts developer productivity. But this convenience is an abstraction, and like all abstractions, it has the potential to leak. It hides the underlying complexity of database communication, which can lead to a dangerous performance trap. The most common and notorious ORM performance pitfall is the N+1 Query Problem. It's a subtle issue that can easily go unnoticed during development, but can cripple an application in production. It occurs when your code fetches a list of items and then, within a loop, accesses a related set of data for each of those items. Imagine fetching 100 blog posts, and for each post, you want to display the author's name. The ORM first issues one query to get the 100 posts. Then, as you loop through them and access the post.author property, the ORM, trying to be helpful, lazily fires off a new database query for each and every post to get its author. The result? One query for the posts plus 100 more queries for the authors. That's 101 round trips to your database for what should have been a single simple operation. Let's visualize the devastating impact of this waterfall of requests. With the N+1 approach, your application fires its initial query to get the list of posts. The database processes it and sends the data back. So far, so good. But then the loop kicks in. Requests author for post 1, wait for the network, response. Requests author for post 2, wait again, response. This sequential chain of requests creates a traffic jam of database communication, where most of the time is spent waiting on network latency, not on computation. Now, contrast this with the efficient, handcrafted SQL solution. You would write a single query using a join clause to retrieve all the posts and their corresponding author data in one go. One request, one response, one network round trip. The database is designed for this. It can perform this join incredibly efficiently. The performance difference isn't marginal. It can be the difference between a page loading in milliseconds versus multiple seconds. The N+1 problem is a classic, but the performance issues don't stop there. As your application's logic becomes more sophisticated, so do your data requirements. You might need to generate a complex analytics report that aggregates data from multiple tables, uses subqueries, or relies on advanced database-specific functions. While most powerful ORMs provide a query builder to construct these complex requests, the resulting code can become verbose and unwieldy, often more complex than the SQL it replaces. Even worse, the final SQL query generated by the ORM's generic translator may be far from optimal. An experienced developer writing SQL directly can structure the query to take full advantage of indexes, use common table expressions for clarity, and leverage powerful database features that the ORM simply doesn't know about. So, is the answer to abandon ORMs completely? Absolutely not. ORMs are exceptional tools for boosting productivity, ensuring type safety, and handling the vast majority of standard database operations. For simple create, read, update, and delete, or CRUD tasks, they're often the perfect choice. The boilerplate code they eliminate is a massive benefit. The secret is to develop an instinct for the speed trap. Identify the parts of your application that are performance critical. These are typically complex read queries for dashboards, search functionalities, or any kind of bulk data processing. For these specific high-stakes scenarios, raw SQL provides the ultimate control and transparency. It allows you to write the most efficient query possible without any abstraction getting in the way. The most pragmatic and powerful solution is a hybrid strategy. Embrace your ORM for the 80% of your application that handles routine data management. This keeps development fast and your codebase clean. But for that critical 20% where performance is non-negotiable, create a clear boundary and drop down to raw SQL. Nearly all modern ORMs provide an escape hatch to execute raw queries directly. This gives you the best of both worlds, the rapid development cycle of an ORM combined with the surgical precision and peak performance of handcrafted SQL where it truly counts. Always remember to profile your application, understand the queries being generated, and never be afraid to write SQL when speed is what you need.